Gravity and freefall. Freefall and gravity.
Gravity is the name associated with the reason for what goes up must come down. Whether it's kids jumping up and down on a trampoline, or Yoenis Cespedes hitting a home run in a Mets game. What comes up must come down.
In physics, gravity is the natural force that causes things to fall down towards the Earth.
In the early 1600s, German mathematician and astronomer Johannes Kepler analyzed known astronomical data in order to develop 3 laws to describe the motion of planets around the Sun. Kepler's 3 laws emerged from the analysis of data carefully collected over a span of several years, and they are as follows. The first is the law of ellipses, the second is the law of equal areas, and the third is the law of harmonies. While Kepler's laws described the motion of the planets, Sir Isaac Newton looked for the force driving this motion. According to legend, Newton's big revelation came when he was 24 years old, when he was hit in the head by a falling apple at an apple orchard in England. After being hit in the head, he realized that all heavenly motion, no, not that type of heaven, yes, that type of heavenly motion, was related to the cause of earthly motion, like an apple falling from a tree, or like this piano falling out a window.
So let's delve a little deeper into this apple.
Using Newton's second law, F net equals mass times acceleration, we can figure out just how much force is working on this apple.
This apple is 0.1 kilogram, and since we are on the planet Earth, we can check our handy-dandy reference table and see that the acceleration due to gravity on the planet Earth is 9.8 meters per second squared.
So let's go ahead and substitute these numbers into the equation. So 0.1 kilogram times 9.8 meters per second squared is equal to 0.98 newtons. Therefore, this apple has a net force, or total combined force, of 0.98 newtons acting on it.
Newtons. It's an appropriate name for a gravitational unit. So the calculation we just did showed the net force of all of the forces acting on this apple at the same time. However, let's take the other forces away and just focus on gravity. An object that is being affected only by gravity is said to be in a state of freefall. So let's look at this apple again. But before we do, safety first. There is a lot we can learn about free fall using this apple. I'm going to hold the apple up and simply drop it. Ooh, nice impact. Can we get a replay of that? Neglecting air resistance and using the time from the video,
we can determine that it took 1 second for the apple to reach the ground. And since I dropped the apple without an added velocity, the initial velocity is 0 meters per second. Finally, we know that the acceleration due to gravity is 9.8 meters per second squared. But since the apple is falling, the acceleration is actually negative 9.8 meters per second squared. Now, using our handy-dandy reference table, we can use the formula d equals VIT plus 1/2 AT squared to determine the apple's displacement. So substituting our values into the equation, we get a displacement of negative 4.9 meters.
Thanks for coming along on our journey, and I hope you were able to better your understanding of gravity and the effect it has on objects. Oh, and remember, always watch out for falling apples. You never know when you're gonna start a revolution.